so today we are multiplying polynomials. This is part 2. What's different about today is today we are multiplying a binomial by a polynomial. Yesterday we multiplied a monomial, so we were able to just, or Tuesday we multiplied a monomial, so we were able to just distribute it out. Today we're going to be multiplying binomials, so that means 2 terms by something. So all your problems today are either going to be 2 by 2, so 2 terms times 2 terms, or some of them are 2 by 3s. So 2 by 2 or 2 by 3. What's 2 times 2? 4. That's why there's 4 boxes right here. What's 2 times 3? 6. That's why there's 6 boxes right there. You'll see us use those here in a moment. Okay, our steps to multiplying a binomial by a polynomial are the same. We multiply our coefficients still, we add our exponents. Those steps of multiplying the coefficients, adding the exponents, always the same. What's different though is at the end, you are sometimes going to need to combine like terms. So like terms are terms that have the same variable, same exponent. So if we have multiple x's or multiple x squareds or multiple x to the thirds, we might have to combine those at the end. So that's the added feature. Right here I have a little note. Every term in the first binomial distributes to every term in the second, either bi or trinomial. We need to multiply 2 by 2 terms or 2 by 3. Because we have to remember to multiply this term by this, and then this term by this, and by this, we are using what we call the box method. The box method organizes our work for us and makes it so that we remember to multiply everything by what it needs to be multiplied by. So down here on our first example, we are going to use this box. We are going to take this 2x minus 5. I'll always take the first binomial. We're going to put it down the side. So I'm going to put 2x at the top row. And then I'm going to put my minus 5 right here. So I'm just splitting that up. So each term gets a row. Okay, I'm going to do the same thing across the top with my other binomial. So I've got x plus 3. I'm going to put the x here. I'm going to put the 3 here. Okay, any questions about that setup? Okay, just like I had imaginary ones I could add in on Tuesday, I have imaginary ones I could add in here. So this 2x can be 2x to the first. And this x by itself can be 1x to the first. So add in those imaginary ones. And then from there, to start filling out our boxes, we're going to multiply to fill out every box. When we multiply, we're multiplying our coefficients, adding our exponents. Those steps always stay the same. So we're going to do 2 times 1, multiply our coefficients to get 2 for this box. And then we add our exponents. 1 plus 1 is 2. So this is 2x squared. Okay. And the top right-hand corner, 2 times 3 is 6. And then adding our exponents, we've got x to the first and no x's. So this x to the first still comes over. 6x to the first. Okay. Bottom left-hand corner, -5 times 1 is -5. And then my x to the first still comes down. And then bottom right-hand corner, negative 5 times 3 is negative 15. Okay. Any questions about filling out the boxes? Sorry, they're working on installing the new screens. That's what all that noise is. Or should be here tomorrow. Okay, so then in that case, we are ready to write our final answer. To write our final answer, we have to put it in standard form, and then we also have to combine any like terms. So to write our final answer for this one, we're going to start with our highest exponent. Your highest exponent should always be in the top left-hand corner of your box. So 2x squared goes first. There's no other x squared, so there's nothing I need to combine it with. Okay, then this negative 5x to the first and this 6x to the first can combine together because they are both x to the first. So we can combine those just like we combined like terms when we were doing 5.1 and 5.2. So negative 5 plus 6 is positive 1. It's going to be plus 1x to the first. And then my minus 15 stays by itself because there's nothing for it to combine with. Okay, any questions about this one? Okay, moving on to our next one then. The next one we've got is 3x squared minus 2 times 5x squared plus x minus 4. So this is a 2 by 3. So that's why we've got 2 high, 3 across. So our 2 needs to go on the side. We're going to put our 3x squared minus 2 down the side here. And since it's minus 2, that's why it's negative 2 right there. Then across the top, we're going to have our 5x squared, our x, and our negative 4. Okay, we can add in our imaginary ones. So the only imaginary ones that we need are on this x by itself can be 1x to the first. And then from there, we're just multiplying. So we multiply our coefficients, we add our exponents. So 3 times 5 is 15. And then we add our exponents. 2 plus 2 is 4. So 15x to the fourth. Top middle row. 3 times 1 is 3. Add our exponents. 2 plus 1 is 3. Okay, and then top right-hand box. Grab one of those. 3 times negative 4 is negative 12. And then this x squared plus no x's here, still an x squared. Okay, any questions about the top row? Okay, looking at our bottom row then. Negative 2 times 5 is negative 10x squared. Negative 2 times 1 is negative 2. And then we've got this x to the first comes down. And then negative 2 times negative 4 is positive 8 for this last box. Okay, so how we fill out the boxes is the exact same. We're still multiplying our coefficients, adding our exponents. Okay, the last thing that we need to do in this problem is we need to combine like terms and write our answer in standard form. Like I said, the top left corner should always be your highest exponent because we have it set up that if we go from high to low here and go from high to low here, then the highest of all of your answer parts is going to be in the top left box. So that 15x to the fourth, there's nobody it can combine with. Then this 3x cubed, there's nobody it can combine with. So it stays by itself too. Then my x squareds could combine with each other. So I've got this negative 10x squared, and I've got this negative 12x squared. The two of those can combine together. Negative 10 plus negative 12 is negative 22. X squared. And I still have my negative 2x to the first. And I still have my 8. Since it's positive, it's now plus 8. So in your boxes, if they're positive, you put a plus. If they're negative, you put a minus. All right. Any questions right now? All right, I'm going to let this video keep going because we're going to do a problem on our assignment together as well. So I'm going to bring you your assignments right now. And then we will get started. We're going to do a problem on here together just because I feel like we need one more. Josh, take this. Hey, there are a few things that happen on your assignment that I can't give you so many examples to see every single thing that might possibly happen. So there's a few things that are going to happen on your assignment that I want to tell you about. First one works out pretty normally, kind of like our first example. On the second one, nothing is going to combine. So if none of your terms combine, then just none of them combine, okay? On the third one of your terms is going to cancel out. When you're combining like terms, if something cancels out, it cancels out. We just don't write it anymore if it cancels out. So that's what you need to know on the front side, that sometimes nothing combines, and then sometimes when things combine, everything's going to cancel out. Let me look at my answer key and pick which one I want to do together. Let's do the bottom right one. Let's do the very last one. It just has the biggest numbers. So we're going to do this very last one together because the other thing that we haven't seen is sometimes there's not just one set of things that combines, there's two sets of things that combine. So we're going to do this very last one together. So we've got 7x minus 3. That's going to go down the side. And then we've got x squared minus 2x plus 7 will go across the top. X squared minus 2x and 7. Okay, setting up with my imaginary ones, x squared, we can make that be 1x squared if we want. And then 7x and negative 2x. We can make those both have a first power. So 7x to the first and negative 2x to the first. Okay, so from there we start multiplying. Instead of narrating this all out loud, I'd like for you guys to try to multiply it, and then we'll come back together and check. So I'm going to freeze my screen, multiply your entire top row, and then come back in and check with me. So you're multiplying your coefficients, you're adding your exponents. So try to get the top row of your table filled out. Okay, checking the top row of our table together. I got 7x cubed minus 14x squared, and then positive 49x to the first in my top row. Okay, now multiply the bottom row. Okay, I got negative 3x squared, positive 6x to the first, and negative 21 in my bottom row. Any questions about getting my table filled out? Okay, so then this is the reason why I wanted to do this one extra example with you guys. When we go to combine like terms, what's my highest exponent? That's a question. 7x to the third, because it's the highest exponent is to the third. We've got 7x to the third goes first. Then, what's my next highest exponent? Okay, so we've got an x squared here. Do we have any other x squareds? Okay, so our next highest exponent is the x squared. We can combine these together. So, negative 3 and negative 14 makes negative 17x squared. Then the next thing we've got 6x to the first and 49x to the first. We can combine those together. 6 and 49 makes 55. Still x to the first. And then we've got minus 21 on the end. Okay, any questions about that problem? Okay, I'm going to go ahead and stop my recording so I can get it uploaded for everyone who just walked in.